My name is Oktay. This video is about glass technology. This picture shows you different structures of solid materials. At the left, you have the structure with the highest order, that's crystalline structure. In the middle, the polycrystalline structure, and at the right, amorphous structure. Glass is an amorphous solid, not crystalline. It is often transparent. It is made by quickly cooling molten substances. Glass has an order, but only at a short range, but not at a long range. Soda lime glass makes 90% of manufactured glass. It is cheap, chemically stable and hard, and it can be recycled. Its composition is 74% silica, quartz, that's the network former, 13% sodium oxide, that's flux, it lowers the melting point, and 10.5% calcium oxide from limestone, calcium carbonate, that's the network stabilizer. And soda lime glass can contain several other oxides from aluminium, potassium, magnesium, iron, titanium, and sulfur trioxide. This is a typical picture of a glass facade. Glass is a very important construction material. In 2021, glass worth of $86.8 billion was exported. The number one exporter is China with about a quarter. Number two is Germany, and number three is USA. That's a picture of borosilicate glass of an Erlenmeyer flask. It contains 75% silica and 8 to 12% boron oxide, and it can contain aluminum oxide and other alkalis. Borosilicate glass was invented by Otto Schott in the 1880s. It has a low thermal expansion coefficient and is stress resistant. This is a picture of Obsidian. That's a natural glass. It's a volcanic glass. It is made of quickly cooled lava. When material from the inner earth comes to the air, it is quickly cooled, then that's exactly the conditions that you need for the formation of glass. It contains 70 to 75% silica and magnesium oxide and iron oxide. Dark color comes from impurities. It is hard and brittle. These are obsidian blades from Syros in Greece from 1700 to 2300 before Christ. Obsidian was a very important material back then. It was used for tools and weapons. You can make a colored glass with iron 2 oxide and chromium oxide. You can make a green glass, and with different concentrations of iron 3 oxide you can make either a yellow or brown glass. This is cobalt glass. It has its blue color from cobalt oxide. There's a long tradition in Bristol, England, of Bristol blue glass, and that's started in the 18th century. This is an example of colored glass. It's the Basilica of Saint-Denis from the 13th century architecture. The glass was restored in the 19th century. And especially if the sun shines through this glass, it gives it a nice look. This is milk glass. It can be opaque or translucent. It is made by dispersed tiny particles. This can be calcium antimonate or calcium fluoride. This is lead glass crystal. The name crystal refers to its appearance, not to its chemical structure. It is made of silica, lead oxide, soda, potash, and other oxides. And since lead compounds are toxic, there is an alternative. It's barium oxide or zinc oxide. Uranium glass contains up to 2% uranium. It is fluorescent under UV light. Uranium glass was popular from the 1880s to 1920s. And in the 1930s, there was a Borosilicate glass. It was a yellowish green uranium glass. And this is a picture of glass ceramic. There are several systems, for example, the LAS system, which is lithium oxide, aluminum oxide, and silica. This is partly crystallized polycrystalline material. There's a special heat treatment that you can adjust the crystallization degree. And glass ceramic is mechanically very strong. It's resistant to temperature changes, and that's why it can be used for cooktop. This is a picture of fiberglass structure. Fiberglass is glass fiber in a polymer matrix. It could be epoxy or resin. It's strong, lightweight, and inert under UV light. This picture shows you the King Kong statue of Nicholas Monroe. It has a height of 5.50 meters and a weight of 890 kilograms. These are two more examples of fiberglass use. At the top, that's a Rutan very easy plane. It's a tiny plane for one person. And at the bottom, dome house in California. It is also built of fiberglass. This is an example of a fiber optic cable from the Southern Cross cable. It's a trans-Pacific network that connects Oregon to California, to Hawaii, to New Zealand, and Australia. It provides a high-speed data connection. The structure of this cable is high-density polyethylene at the outside, then copper tubing, steel wires, and in the inside there are optical fibers that are embedded in a water-resistant jelly. This picture shows you glass wool. Its manufacturing is similar to that of cotton candy. And glass wool has many air pockets. That's why it's a good thermal insulation material. But you have to be careful when you are working with this material. Yeah, that's why this person has a mask. This picture at the top shows you the formula of Plexiglass. That's acrylic glass, polymethyl methacrylate polymer. And at the bottom you can see the structure of the monomer, methyl methacrylate. The polymerization is possible because this double bond, carbon-carbon double bond, has a lower bond energy than two CC single bonds. That's why this reaction is exothermic, and that's how you make plexiglass. Here are two examples of its use. At the left, that's a picture from the Olympic Stadium in my hometown of Munich. The stadium was opened in 1972. Its roof is made of plexiglass. It is very strong and lightweight and very resistant. At the right, you have an acrylic wedding invitation. This picture at the top right shows you the structure of bulletproof glass. That's a layer structure of laminated soft and hard glass in plastic sheeting. In this picture, the gray material. And the soft glass is as important as the hard glass because the soft glass gives this structure elasticity. And bulletproof glass is used for armored vehicles and in high security buildings like, for example, embassies. This is a picture of Gorilla Glass. That's chemically strengthened alkali aluminosilicate glass. It's strong and lightweight. Gorilla Glass is used for mobile devices, TVs, and laptops. The origin of glass marbles is not clear. It could be Venice or Germany. In 1846, the marble schere was invented in Germany. Marble schere means marble scissors. And this tool made glass marbles possible. The first machine-made glass marbles came in Akron in Ohio, USA, in 1903, and they were made by Martin Frederick Christensen. This is a nice picture, a painting of Karl Witkowski. It's called Boys Playing Marbles. This is a picture of glass art. That's amber glass ornaments. This is a nice picture of a glass bowl. This is a glass-blown horse from Venetian island of Murano. Venice has a very long tradition of making glass products. And this is my personal favorite. It's a very beautiful art from Bangkok Glass. That was today's video about glass technology. Thank you for watching. Have a nice day. Bye bye.